Okay, so to calculate or to make a residual plot, you need to work out your prediction and subtract from that your raw data. To calculate your prediction, you need your equation. So if you go get summary, here's your equation. 0.87 times the weight, okay, times the x variable, plus 0.66 will give you a prediction of your lean body mass. Okay, so what I'm going to do here is manipulate variables, create new variable, call it prediction. Oops. And type in that formula. 0.87 times weight, and don't forget to give it a capital WT, plus 0.66. Right?
Is it plus negative 0.66?
Thank you, it is too. So rather than plus negative, I'm just going to write negative 0.66. Okay, submit, and hopefully we get a light bulb. Yes, we do. Okay, and down here we'll have a variable prediction, a variable called prediction. Okay, I'm not going to plot prediction just yet. I'm now going to create my residual variable. Okay, so add another variable and call it residual. And this is the one where we go prediction minus raw or raw minus prediction. Now in this case, the raw is lean body mass. So that on here is called LBM. I'm actually going to go prediction minus raw. LBM. Thank you. I wouldn't have got the white. Uh-oh. So I wonder if this is to do with the gaps I've put in there.
Yeah, there's a space at the start.
Oh, good spotting. Capital P. There we go. Prediction minus L lean body mass. Okay, now we can plot our residual, and I'm going to plot that on the y-axis. Okay, that's what it looked like for the time series. It was on the y-axis, and I'm going to plot on the x-axis my weight, which is, remember, the independent variable. So keep weight on the independent variable, and if I get rid of that, that is a plot of my residuals. Anyone see something wrong with my residuals? I'm just going to, that line in there is meaningless, so you can get rid of it. Thank you, remove additions. What would you expect to see on this horizontal axis if it was a true residuals graph? Look at the scale, minus 50. Yeah, we don't see any positive values. So there is an error somewhere. Okay, so a few troubleshooting errors there, but it was a good test. It was a good test really to quickly observe that you know that what a residual graph looked like, and you should know that the scale should have some negative values plotted and some positive values plotted, and if it doesn't, you know you've made a mistake. So hence I had to go back make a new prediction and a new residual graph. Residuals go on the vertical, the independent data variable stays the same. Get rid of that blue line because it means nothing. By remove additions. Okay. Now, what you're looking for on this residual graph is absolutely no pattern. So it should be a random scatter of plots, and that's what you're looking for. Obviously, this is an outlier on this graph, and if you transpose it to the original graph, you'll also see that value well above the model. Sometimes on these graphs, on these residual plots, you'll note that the first half of the plots will be above in the positive. There might be a group in the negative and then a group in the positive again, or some combination of a pattern, and therefore we would determine that the model that we're using is not that appropriate. Okay, if you like this one, it shows, well, there's two explanations. There's the correlation coefficient of 0.97. That explained to us that was a good model. Not only that, we've got a very random scatter on our residuals plot saying to us that it is a good model if it's random. Okay, we can work out some percentages. Okay, 5 out of the range, these residuals are good, okay, because they're not too far scattered from. Ideally, if we had an R value of 1, the residuals would all be 1. Follow that? If you had a perfect model, which as I said doesn't ever happen in real life, then your residuals should all be 0.